Okay, so let me first explain to you how to access the resources which I am sharing with you. Okay, so the first step is go to this website freegyan.org/Gyani, and there you click on this IV physics. Click on this IV physics. It will take you to this page.
So the
So
clock's
in this
wrong in
page-
house.
Guys, you need to be on time.
So
Otherwise,
the clock is wrong in house. The biggest rang the bell rate. I have to what happened.
okay. Thing is, I will start on time. Even if one student is here, I will start on time. Okay, so I was telling them that all the IV resources, like our class recordings, video recordings of our classes, and even the notes which I use while teaching, and the lab assignments, worksheets, everything will be in one place for you to access. So it's all in my website freegyan.org/Gyani. I have sent you the web link also. So if you go there, you will see on the top menu IV physics. Okay, just click on that. You will get the playlist. So this is the playlist. If you mouse over here, it will show you all the videos which are in that playlist. And the videos have been named topic wise. So whichever topic you need to revise, you can just click and go through that. So the first playlist is your class recordings. The one below it is the previous year. The one below that is the year previous to that. Okay? And then here you see the link to the OneNote file. So if you click on that link, you will come to this OneNote file. So here if you go to labs, you will see what all labs will be doing. So labs are required for you to learn the experiment skills. How to take measurements and how to plot graphs and all that. So it is required for your internal assessment which has 20% weightage. Clear? And in your paper 3, you will have section A which carries 15 marks. It will have questions based on these techniques. So they will give you some data of some experiment and ask you to interpret the data, do all the error analysis techniques. Okay? So for that you need to do the labs properly. So don't give it more than 2. It's too noisy. Give it at 2. Yeah. So the instruction sheets, whatever is the rate for the lab, just read it and follow it. So all the labs you will be using an Excel spreadsheet for your observation table and calculations. Right? So this is being done for your practice. So IT is not going to check your work, but I need to have a compilation of your work as evidence that we did the labs. Because IP says that we have to spend so many hours on labs. So for that documentary evidence, I need you to bring me the work which you have done. But otherwise, I don't want to trouble you unnecessarily. Okay? So do it for your practice. So it should not be like one person does the experiment, all the calculations, and then all of you save the Excel file as different names and mail it. That's of no use. Whatever you do, just send that as an evidence for me. Okay? It's for you to practice the skill. Clear? Okay, so now this is the first lab, so I will do along with you. So you will do along with me to practice. Clear? So I'll just explain to you what we are supposed to do in this lab. So you will learn all the skills of how to make measurements and do the calculations with uncertainties. Okay? So for every experiment you need a research question, and I told you the format of a research question. So RQ is the short form for research question. It should be of the form, how does some measurable quantity Y depend on another measurable quantity X? Simple, right? So suppose you are given a lump of clay. I want you to think about what kind of research question you can create in this format using this lump of clay. Come on, think. As soon as you come up with a question, raise your hand. Yes.
So weight and the diameter.
Okay, how does so which is y, which is x?
So weight is the diameter. So weight is the y. Weight is the y and diameter is the x.
Excellent. So that means what is being controlled here?
So weight.
No.
Sorry,
No.
what is being controlled?
Control means you should keep that variable constant.
The type of clay.
Okay, good. Then
Density, same density.
density. Then
Amount of fluid.
no. If you use the same amount, then how can you change the diameter?
Then shape.
Shape. Excellent. So you pretty much covered everything. The type of clay, the density of clay, the properties of the material of the clay, shape of the clay. So if it is ellipsoid in one case, geoid in another case, cubical in another case, then it will be a problem. You should make it into as much perfect a sphere as possible in every case. So the question which came to you first, that's what we'll do today. So our research question is going to be, how does the mass of the plasticine or clay depend on the diameter of the spherical piece of clay? Clear? Understood?
Yes.
And both are measurable quantities, you can check it. So to measure the mass, what will we use?
Micrometer. No. We use meter root.
Mass.
Mass. We will use a weighing machine.
Electronic balance.
Electronic balance. Yeah.
Okay, and to measure the diameter? Vernier caliper. So we will use this vernier caliper. All of you have used it before in B form, right?
Yes, sir.
So you know how to use it with least count, everything, right? Zero error, zero correction. Okay. So that's what we are going to do. Let me get the electronic balance. All of you open Excel in your laptop.
Excel sheet.
All of you open Excel in laptop. If you don't have, then you could sit with someone who has. Otherwise, just follow along as I do it on the screen. Okay. So now we have 1, 2, 3, 4, 5 lumps of clay. So divide yourself into 5 groups.
5 groups.
Yeah, because we have 5 sets of experiment apparatus.
4 groups in our class. You can have 4 groups of 2.
So one can do alone also.
No, you can have 4 groups of 2. You want 5 groups?
Yeah.
You want 5 groups?
One can do alone. Whoever wants to do it alone can do alone. One person. Who wants to do alone? Hurry up.
I'll do it.
Okay.
You want to?
You do alone. You are sitting alone.
I'll do it. Bye.
Here. Okay, catch Vedant. Careful. Okay, then you need vernier calipers. This I won't throw.
The rule is when you get.
It may stab you.
I'm not say that. Yeah, you can.
Okay, spreadsheet is open. Okay. Now let me also open the spreadsheet. Zoom in. Okay. Now, whatever I tell you now, do as I do it on the board. Okay. It's very important to understand that these are all the general methods for all experiments which you do in future. Every research question which you have, the procedure is same. So the first few rows of your spreadsheet will be reserved for noting down the common parameters, like the basic parameters. Please remember that whenever you do an experiment, when it's a science experiment, the main criteria is it should be reproducible. Someone in some other part of the world, if he wants to repeat your experiment, he should be able to repeat it and get the same result which you got. So suppose you chose a particular lump of clay, and in Australia the clay is made in a different way. It has different material properties. And you didn't mention what type of clay you used, and he used the clay of Australia. Then his result may vary. Then he may say that you have cooked up your data is false. So you have to be very clear what you used so that the other person can repeat exactly the same way. Right? Suppose you did the experiment when it is 40 degrees Celsius and the other person did the experiment when it is 10 degrees Celsius. The clay may have different material properties due to the different room temperatures. Then his result will differ from yours. Then again he will say that you did something wrong. So you have to mention the room temperature, atmospheric pressure, all the conditions of the experiment should be mentioned in the beginning. So that the person who repeats the experiment can also ensure the same conditions. Clear? Or he will note down his conditions and he can explain why his results differ from yours. It could be due to this difference in conditions, like that. Clear? Okay, so in our case, what will we note down? It's just clay. There's nothing more specific to mention. Is there anything else? Properties?
Normal household clay, the room temperature.
We won't go into that detail now.
Okay.
But in your IA, you have to do all that. So first few rows we'll leave for that. So now we'll go to the main observation table. So somewhere here we'll start. So first column has to be serial number. So type it. Serial number is the first column heading. The next column heading is going to be your independent variable. Since it's your first time, I'm just giving all those hints here. But you will directly write the independent variable. So independent variable in our case is going to be the diameter of clay ball. So you will always follow the convention that you will first describe the variable name and then you will give a symbol for that variable name. So in our case the symbol will be small d and then you will put a slash. Slash is the separator between the symbol and its unit. Okay? So unit will be in centimeter. We will use the convenient unit, centimeter. And then you will write plus or minus, which will tell you the least count of the measurement. So for that you go to insert, symbol, and where is this? Ah, here it is, plus or minus.
I'm getting emojis.
Insert symbol. So you have to select it from that, okay? And then click on insert button, close. So what is the least count of our 1 year caliber? 0.1 centimeter. Why did that suddenly become so huge? Okay, then go to, see, one more initial trick you can do is click on this top left corner of the spreadsheet. It will automatically select all the cells and then click on wrap text. So that every text which you type will be inside the same cell.
Oh.
Okay?
Where's wrap text?
Wrap text is this button.
Okay, found it.
Okay, so independent column is done and serial number will usually put 8. So independent variable should be changed 8 times in every experiment typically, so that you have 8 data points in your graph. Clear? See, each value of independent variable will give you a different x coordinate in your graph of y versus x. Independent variable will be on the x-axis. Dependent variable will be on the y-axis. So if you have 8 different values of x, you will have corresponding values of y, so you will have 8 different data points. You will get a smooth graph, smooth curve, which will tell you what is the relationship between y and x. Okay, now you will write on the top row the dependent variable. Dependent variable will be your mass. And we will give it a name as small m / grams and then plus minus. Insert symbol plus minus. It will be 0.001 no 0.01 gram. Then check it. So you have to click on, press the on button and then keep it on a stable surface.
0 near the tower.
Right now it is showing 43.3, so click on tab. So now it shows 0.0. So, and the unit is grams. So it should up to 0.1 gram.
0.1.
Yes. So always whichever instrument you use, note down the least count. And you will be doing at least 5 trials in a typical instrument.
You said
In our
8.
case, no, trials is different from number of independent variable values. Trial is
You can
the
predict.
same dependent variable measurement, you will repeat 5 times. That means in our case, you will take the clay ball, repeat its, measure its mass. Actually, mass is easy to measure as a dependent variable. So I think we should make diameter as the dependent variable. Let's see what is given in the instructions. Okay, they have taken independent variable as mass, dependent variable as diameter. That makes more sense because it's more difficult to measure the diameter using only a caliper.
Interswitch.
Yeah, so just switch it.
How do you do that? Can you switch that?
Just Control X, Control V. Here you Control X, Control V. So mass of clay ball becomes an independent variable now, and diameter of clay ball becomes your dependent variable. And you will do 5 trials. Trial 1, then copy paste it. Then just change the number. Many students type it incorrectly as trail 1, TRAIL. It's very annoying. Please don't do that. I have corrected so many IAs where students have written trail 1, trail 2. Shows a lot of carelessness. So this is the standard method, and then you will have the mean value of all these 5 trials.
Why have you shifted the diameter thing up?
Why is the diameter thing off?
Because it's the common heading for till here. So now you will click on this and merge it. This is the merge button below the wrap text. So diameter you will take 5 trials, and then you will calculate the mean of the diameter, and then you will calculate the uncertainty in the measurement of the diameter. So here you write uncertainty. And for all of them the unit is centimeter only, and the precision is 0.1 centimeter only. So this is a common heading for all these 7 columns. That's why I have put it on the top. So this is the standard format of an observation table for all your experiments, your internal assessment also.
How do you comment it?
Just click on that first cell and then click on all the remaining cells also. Click on merge text. This is the button, merge. Merge and center. Done? You want me to do it again?
Done, sir. Yeah.
See here, you wrote it in the first cell. Next, click and select all the remaining cells which you want to merge. Got it? And then click on merge and center. Here. Okay, now we need to enter the formula for finding the mean.
Sorry.
So here click on the cell under the mean and then say equal to. The moment you type equal to, it starts accepting formula.
C7 plus.
So I just click equal to and then you want to select all the cells, or no, before that average. So just say AB. Excel has formula for everything. You don't have to write any formula, it has everything inbuilt. So just type AB, you will get average function, double click. Okay? After double clicking it, select the 5 cells whose average you want. And then click here and close the bracket. And then press enter. Then since you have already typed serial number till 8, now if you just click here, go to this bottom corner and double click. Okay, it's not working, so just drag it.
Okay, double click.
Sometimes if you double click that bottom right
Yeah, it
corner
happened.
handle, it will automatically fill up the table with formula for the remaining cells. Now Excel is so smart, it adjusts the formula according to the row. Here it is C8 to G8, C8 to G8, Here it is C14 to G14. So it automatically changes the formula correctly. Till mean, everyone finished updating your formula?
No, sir.
Yeah, so.
Do it and then let me know.
And so uncertainty, we'll have to measure.
I'll tell you how to calculate the uncertainty using the max minus min by 2.
So can we do that in the Excel?
Yeah, of course. Everyone has finished till mean? Is there anyone who has not finished till mean? Raise your hand.
One second.
Okay. Raise your hand once you are done till mean. Done?
CD.
Done?
Go to me.
Okay.
Excel or page?
So now for uncertainty, see how we do the formula, how we write the formula equal to,
Equal to.
you want to find the maximum value out of these 5 trials, right? So Excel has a function called max. Anna, are you listening?
So one second, sir.
What?
So there's a bit of confusion. It's not Excel, MA.
I advise you to install Excel, otherwise it will be difficult.
MEA. So there's no mean in this.
It may be average.
Average, right?
I use the formula average.
Yeah, average. And now drag drop this down. No, because trial, go to trial 1, what's underneath it, select it and drag across the trial side. No. That's it. And now just.
Rahul, Excel is available for Mac also.
That's not getting it. I'm getting it.
Yeah, get it. Otherwise it will be difficult for me to explain.
Yeah, sir. Okay.
Done?
Yeah.
Okay, now for uncertainty, we will use max minus min by 2. So just type MA, you will get the max function.
Yeah.
Double click it, select all the 5 trials cells, close the bracket, then do minus of, now type MI, you will get the min function, double click it, again select the same 5 trials, close the bracket. Now this whole thing has to be divided by 2, so put this whole thing starting from the equal to sign, to the right of equal to sign, open a bracket there, then close the bracket again. This whole thing has to be divided by 2. So now drag and now click that cell and drag it down. So the formula is automatically updated for all the remaining cells.
So I don't understand.
Who didn't understand?
What do you mean then?
Not mean is done.
Yeah.
Now click on the uncertainty cell, type equal to, see the formula which I have typed.
Can I just remove that thing so I can't see?
Oops.
Max. See.
I'll open a notepad and type the formula.
Got it, sir.
This is the formula you have to type in the uncertainty cell. Max of the cell range. Select the cell range of 5 trials. Minus min of, again select the same cell range of 5 trials. Put the whole thing inside brackets. Divide by 2. Done?
Divide by 2.
Yeah. So when you do max minus min, it gives you the total ranging fluctuation of your measured value. and half of that range is the uncertainty. Got it?
This is it. For
Yeah, this is it for the observation table.
And we have to stretch it.
Now we have to,
all trials. All.
yeah, now then drag it down for all the remaining 8 independent variable values. See, these are not called trials, these are called different values of independent variable. Trials are the same value, same measurement when you repeat 5 times, that is trial. Okay? So now once you populate it, okay, I'll tell you one more thing. When you do your internal assessment, you want to find the relationship between the dependent and independent variable, right? So if before you do the experiment itself, if you decide what will be your independent variable values, it's not a good idea. It's not a wise approach. Because see, suppose in our case, we decide that we'll just take whatever mass this. So in our case, what we'll do is we are going to change mass, right? So this is the total lump which we have. So always your goal is, your thinking process should be that I want to change the independent variable over the widest possible range which I can, so that I can find the relationship over the widest range. Are you getting it? So now the maximum mass I can have is this, because this is the total lump of mass which I have. So this will become my maximum value here, the bottom one. Agreed? And the minimum is determined by the least count of my instrument. If my instrument can measure only 0.1 grams, I cannot have 0.01 gram as the smallest mass. Agreed? At the same time, I should not use 0.1 gram also as the smallest mass, because what will be the relative uncertainty of my measurement? Anna? If my electronic valence has a least count of 0.1 grams and I choose 0.1 gram, a small piece, is it a good idea?
No.
What is the percentage error?
So the point 100 to that?
100% error. So if the least count is 0.1, you will not choose 0.1 as your smallest mass. It's waste to measure that using this instrument. So we'll use at least 5 grams. So that 0.1 gram, if it's uncertainty in measuring 5 grams, it's negligible. Clear? Okay, so how we will do it is, to guide us about how to change the independent variable values, one trick which we will do is, this empty table itself we will connect to a graph. So that as I enter the values in my empty table, my graph will start giving me a live update of how the relationship is emerging. So if the curve suddenly changes somewhere, see, listen, suppose I put the data points here and the graph is showing me that my first data point was here. So suppose I took the smallest mass, it was here. For smallest mass, the diameter was also small. Then I will do the maximum mass in my range, which is somewhere here at this point. And for the maximum mass, the diameter was also maximum. So let us say it came out to be somewhere here. So then it means I am going on the right track. As I expected, when mass increases, diameter also increases. So next what I will do is, I will take a mass which is halfway between these two. So some mass which is here. So I expect the diameter to be also halfway between these two. Or if you have done the derivation, if you expect that diameter will, see, if you expect diameter to maybe drastically like this, suppose, instead of linear, then your expected diameter will be somewhere here. Then you take a mass which is halfway between these two, it should be somewhere here. Next you take a mass halfway between these two, it should be somewhere here. Like this, if you select carefully, the data points will give you the proper shape of the curve which you expect to verify. Are you getting it? So, whenever you do your internal assessments, a smart thing is to also get one more column, predicted value of the dependent variable, to guide you about how to choose your independent variable, so that you get a good graph. So let me show that also to you. So in order to be able to predict what is to be expected, you need to derive the relationship. That is called modeling. So we know that density is mass by volume, right? let's use the symbol rho for density because small t is already used for diameter. So rho equals m by v. M by, now volume is, since it is sphere, what is the formula?
Volume.
4 by 3 pi
4 by 3 pi.
r cube. But we are going to measure diameter, so it will be diameter by 2 the whole cube, which makes it 4 by 3 pi d cube by 8. 4 to the 4, 4 to the 8, so this will become 6. So m by pi d cube by 6. This 6 will come to the numerator.
About 3. About 3.
That's what 3 2s are 6. So that 6 comes to the numerator. And this is rho. Rho is supposed
Why
to
are
be
you
constant.
calculating density?
I am not calculating density. I started with a relationship between mass and volume, which is density.
Why does 6 come to the numerator?
See, if you have 2 divided by 3 by 4, it can be written as 2 into 4 by 3.
Yeah.
Right? That same thing we have done. M divided by something by 6 is same as M into 6 by that something.
Okay.
So our goal is to find the relationship between the independent variable which is mass and dependent variable which is diameter. Agreed? So we need to make diameter as the subject of our equation. We getting it? If you do that, we have found a prediction. That is our hypothesis or model. So in this diameter cube is here, so bring it to this LHS. So diameter cube is equal to 6 by pi rho into m. So this is the relation. So if you plotted diameter cube versus m, it would be of the form y is equal to mx. The y is diameter cube, x is your mass, and m is the slope. So slope m would be 6 by pi rho. And you expect the data points to pass through the origin. So in every experiment you do, your internal assessment included, your goal is to get a linear graph, so that from the slope you can find something useful. So in this case we can measure the density of the clay from the slope of this graph. So if it turns out to be correct, then it verifies our model. And if the data points line is a straight line which passes through the origin, that also confirms our prediction. Are you getting it? Clear? So first we will plot diameter versus mass. So we know that so if you plot diameter versus mass, it will vary as cube root of mass. So diameter is equal to cube root of 6 by pi rho into m. So it should be varying as cube root of mass. So whatever the shape will be. Next we will plot the second graph, which is diameter cube versus mass. So you will have two graphs. Diameter cube versus mass. This one we can predict it should be a straight line with a constant slope. And
so why do we have two graphs?
the first graph just shows you the shape, the relationship of between the raw data directly. But you can't, if you get a curve something like this or something like this, you don't know what is the exact relationship. You can't fit a curve for that, function for that. So now you will predict, you will guess what should be the function. So from our theoretical derivation, we expect that it should dq versus m should give a straight line. So now if you calculate dq versus m and plot it, in Excel you have a function called linear fit, as well as in LoggerPro. So it will give a best fit straight line passing through these data points. And then it will also tell you the equation of the straight line, y equals mx plus c. So from that equation given by Excel or LoggerPro, you can calculate the slope. So it will tell you the slope, and you know 6 and pi value, so you can find the density of the clay. Are you getting it? We'll do it, it will make it, it will be clearer. So now that we have identified, we have to plot diameter Q versus M. So now let's code the graph in, let's make the graph before even the data is started, before even the data is collected. So that once the data collection starts, it will give you a live update. So to make the graph, what you need to do is, we'll be plotting graph with the mean value of dependent variable on y-axis and the equivalent variable on x-axis. So this, let me highlight in yellow, mean also in yellow, between these two. So click here somewhere below the table, then click on insert, scatter.
Sorry, wait just one second.
Yeah, insert, scatter. So always follow the same convention. Once the observation table is done, below it you make the graph. So insert, scatter and select the very first one without any connectors, just the dots. Then drag and place it below and make it of a decent size. Done till here, you see an empty graph. Done?
Yeah.
Now right click, select data. Right click on the empty graph, then select data and click on add series. So here series name you just type M versus, no, whatever is on y. This is again very important. Whatever is plotted on the y-axis, that should come first in the name. So we are plotting diameter versus mass. Okay? And then in series x values, you have to select the x-axis data points. So click on this button and then go to x-axis data point, which is the mass, and select all the cells. Again click on this button. Now series y values, select the y-axis data points. Click on this button, go to the mean and click select all the data points. Click OK and OK. Next, we also need the linear plot. So for that, we need to calculate d cube. So here,
it's a 0.1, 0.2, 0.3.
Yeah, that's okay. Don't worry about all that. We haven't even populated the data yet. Once the data is entered, the graph will change automatically. Okay? Now let's calculate the diameter cube. So diameter. So
So I
let's
can
just.
understand this part.
Which part? Okay, wait.
All of this.
This graph part.
Yes, sir.
See, did you right click and insert a scatter plot?
Yeah.
Do we have to highlight both of them?
Now click on select data. Have you done that? Yours is Mac, so it may be somewhat different from mine. Okay, Arnav said you got it right? Arnav?
Yes, sir, I got it right.
Okay, walk around and help whoever didn't get it. Whoever needs help, please raise your hand. Arnav said you didn't get it. Okay, look at his laptop, see how he's doing.
He's not helping me. Yeah, wait,
Okay, we'll do one thing. Arnav, just pause. Ane,
So,
first listen to it once. I'm not going to hurry, don't worry, I will repeat it again next time. Anyway, it's getting recorded, right? So let's finish one set of instructions, one round of instructions now. First listen and watch, and then you can try by looking back at the video after the class also.
y will be mass. No.
Y is the
Diameter.
mean values.
Acha, why
Mean
if you
values.
just tell us how to insert this graph?
That's what. See, I will do it again. See here. Just click on any cell here below the observation table, okay?
Yeah.
Then insert menu.
Yeah.
You see the scatter?
Yeah.
Click on that.
Sorry?
Out of all the options, click on the dotted one.
You know, so do you edit the sizes? The option of editing sizes.
No, don't do anything about editing size right now. Just have an empty graph like this. Clear that, Ane?
Yes.
Now right click on this empty graph.
Yeah.
Select data.
Right.
Now you have to add series.
Right.
Each series which you add will be a set of data points.
Right.
So now give a name to the series. We are going to plot diameter versus mass. So D versus M. Done? Done?
Yeah.
Now you have to select the x-axis and y-axis values. So as series x values, click on that button and select the mass.
Right.
Then select the series y values by selecting the mean.
1 second, sir.
Mean diameter.
Okay. And series Y value the
Mean diameter. Then click OK, OK.
done. Then
Okay. So now your empty graph is done for diameter versus mass.
right.
Now you need to do diameter cube versus mass. So the new column after uncertainty, write D
Edit करना
cube. So see here, first write D3
select it. Right.
and then select only the 3
Okay.
and then right click. Go to format cells,
What do you keep the series name?
D cube. No, which series? This is the second graph.
In the first graph.
First graph is D versus M. So now select superscript.
Where's superscript?
In format cells you will see below FX.
X value.
Then OK
X value should be.
and then give a space slash. No, again remove that superscript. Again select that slash.
Yeah.
Remove that superscript effect.
Okay.
Now write diameter cube will be centimeter cube, right?
1 second.
Centimeter 3. So I have just written the column heading as diameter cube in units of centimeter cube. Okay? Then you will also need to, when you are plotting a graph of diameter cube, you need uncertainty in that also. Uncertainty D cube. That will also be centimeter cube. So again make 3 superscript in each case.
Uncertainty in DQ.
Yeah. Okay. So now D cube. The formula is equal to whatever is the mean diameter, click on that and then put the power symbol and type 3. So I have made it cube. I just made a cube of the mean diameter.
But then uncertainty by CM
Yeah. It's not by CM cube, it's slash CM cube. Slash is the separator for the separator of the unit from the variable name.
Okay. Then what do we do?
Now uncertainty we will calculate later. For now you just need to enter the formula for diameter cube.
Okay, 1 second.
Done till formula for diameter cube?
1 second. Formula for diameter cube is
Just click on that equal to and then click on this mean diameter cell and then write to the power 3.
so we do equal to
Equal to, click on this symbol. Click on the mean diameter, the first, this cell.
right.
And then type power symbol in your keyboard.
Yeah, where's the power symbol, sir? Oh, got
It will be above 6.
Shift 6.
Shift 6. And then type 3. So this means the computer will do mean diameter cube. And then drag the formula down.
We have to drag it to under.
Drag it till the 8th row.
So what's the formula, because I was helping them out to be
Formula is just type equal to, see here, equal to, after typing equal to, click on the mean diameter, it will take the cell address of that, which is H7 in my case.
Yeah, even in mine.
And then click on this formula bar and then type power
it to all the cells.
Yes, you can copy and paste the formula in all the cells, that will also work, or you can drag the formula down. Uncertainty I will tell you how to calculate later. Now let's make the graph of d cube also. So click on the cell near to the first graph. Again insert, scatter, plot. Then place it here. Adjust the size so that it's convenient size.
Select data.
Yes. Right click, select data, add. Now series name you just type D power symbol Q versus M.
So D power 3 versus that.
Yeah. And series X values will be your mass. So select all those cells. And series Y values will be your diameter cube.
Series X value will be
Mass.
okay.
Series Y value will be the diameter cube. Then click OK. So to show that this is also being plotted, I am making it in
So the
light blue color.
X values will be the
Mass.
Okay. And the Y?
Diameter cube, D cube. Okay. Now we are all set. So we will start with the maximum mass, which will be the. So always your data should be an ascending order of independent variable. Always. So the maximum mass will be the 8th value. So now let me measure. Let's do quickly. Yeah, x-axis values are same in both the
So
graphs.
in the Y values will be this one.
D cube, yes. So I made it into as good a sphere as possible. Diameter cube for second graph. For first graph it was just diameter. Okay, now I am placing it on the electronic balance. I am getting 66.9 grams. 66.9.
For the second one.
So I will put it right at the end.
That is the maximum mass I am going to do in my entire experiment.
Put it.
So it's in the last. Okay?
Or the diameter.
Decreasing order.
Yes.
In ascending order. The first row should be the smallest value of mass.
But you are doing the other way, only that. You are doing the biggest first.
No, while doing the experiment, since I started with a lump of clay in my hand, I'm just the entire clay will be the maximum mass, so I'm doing that first.
Okay.
So I'm putting it in the last row. Okay? Now, one more thing. Always you should have a good habit of writing the axis labels before itself. So that when you show me your graph, work in progress, I can see clearly the labels of the axis. So let's do that also. Click on the graph. And then you see your design chart tools. In chart tools, go to design. No, not design, layout. In chart tools, layout, chart, axis titles.
So once I'm there, I can see.
In chart tools, layout,
Where is chart 2?
you have to first click on the graph.
Yeah, okay.
Then chart tools, layout. Either right click or find out where it is. Computer varies. And then go to axis titles. Primary horizontal axis, title below axis. And then I'll just type it as M. Again, variable name, mass, comma, variable symbol.
So axis titles.
Yeah.
Okay.
Variable name of axis, comma, variable symbol of axis slash unit.
Okay, so yeah, I'm now getting the
Right.
X and Y. You get it? What kind of X axis and Y axis stand for?
Similarly, now again go to axis titles, primary vertical axis, rotated title. For vertical axis, select rotated title and then
We found it.
type it as diameter of clay ball, comma D slash centimeter. So the axis labels should be very clear. Now this legend I don't need, so I'm deleting it because there's only one legend is required if you have more than one data sets being plotted. Since only one data set is plotted, I don't need a legend here. So similarly for the second graph also insert axis titles, primary horizontal axis title, below axis. It's going to be mass M in grams. Again insert axis title, vertical, rotated title. It will be d power 3 slash centimeter power 3. Okay? Now we are all set. So trial one. So now do the experiment. Now let me measure the diameter. So 5 times how will you measure the diameter of the same object? Measure it in different directions. First measure like this, then rotate the clay ball by 90 degrees, measure it again, then rotate it by 90 degrees, measure it again. Yes?
Screw down a little bit.
What do you want me to do?
Screw down a little bit. Yeah.
So just measure it in different directions. And what are the precautions? Don't crush the clay ball and change the shape. So keep it gently and measure. So let me take the diameter now. Okay, the first diameter is 4.5. No, 4.05. Yeah, 4.05. So let me write it quickly. 4.05. Then next time. No, you don't copy my values. You do your experiment.
We don't have.
I have given you clay and vernier caliper. So all of you do your experiment yourself, get your own data. Mass you can take your clay ball, keep it on the electronic balance, measure your mass. Measure the mass of your clay ball. Do it. Each of us will have different data. Now do it. It's a competition between you and me. Let's see who finishes all the data collection first.
You have that upper hand right now.
See, you cheated. She started earlier.
I am old, you are young.
It's not like you have to sprint a race now. 62.2.
Okay, now I think we can stop the recording or at least pause it. Pause it, Rahul. Pause. Okay, so now you can see that for the 4 data points which I have managed to get during this time, the D versus M graph is showing a curve like this, a gentle curve like this, and the DQ versus M is showing a perfect linear fit. Yeah. Okay, so we'll continue in the next class how to fit the curve and how to add error bars.
So आपने कुछ गलत किया आपने कुछ ग्राफ